All right. Can you hear me okay? Okay. Thank you so much for coming in. Good evening. I think this is the last session that you are going to attend for today, right? Okay, so the actual reInvent starts after that. Okay, so before we get started, just show of hand, how many of you are aware of generative AI? Okay, that's good. Yeah, today I was just coming in Lyft, and the driver was actually asking me that, is it going to be around machine learning? And I just had one dry run in front of him. So this is exciting times. My name is Suman Devnath. I'm a principal developer advocate for data and machine learning at AWS. And today, we are going to discuss about how you can leverage vector database or vector store with machine learning, or in a very close context with generative AI to build smarter applications. Okay? So to get started with, machine learning is nothing new, right? It has been there for many, many decades. But what has happened in the recent past is with the proliferation of data, the enhancement of machine learning technology, and the compute resources, and the network resources, and the storage resources that we get today, customers are reinventing their application in a better way, right? So this is nothing new, but the resources that we have today, it was not there a decade back. Now, when we talk about machine learning at Amazon, we have been doing this for the last 20 years or so. And if you take an example of our e-commerce solution or e-commerce website, we have many products. And if you look at those solutions from a machine learning perspective, you will know that many of the recommendation systems, the search engines, all are powered by machine learning. Similarly, for our warehouses, the shortest path, to find the shortest path for the robotics to go from point A to point B is powered by machine learning. And similarly, Alexa, or if you are using any of the devices in the Alexa family, those all are powered by more than 30 machine learning systems in the backend. So whether you are developing something or you are using something in your day-to-day life, you are actually consuming machine learning in some form or other. Now, in this context, what has happened is, in the recent past, I guess in last 1 year, with the upcoming of new technology, specifically in the generative AI, has changed the whole dynamics of how we do machine learning, right? So few of the crux of generative AI is that it can create new content, it can create new conversation, new images, new videos based on your problem statement. So this is a very difficult problem if you think about it, right? But now we have taken it for granted that we can ask any question of any domain and I will get the answer. But if you think about the same problem 5 years back, it was almost impossible to get some solution around that. Now this all have happened thanks to generative AI. But at its core, it is nothing but a machine learning model, right? But this is a little bit different than the model that we used to have. And the difference is that here we train a model with billions of parameters, or billions of weights, and we train the model with a large corpus of data of internet scale. So this is not the data that we can store in our laptop or a server and then start training it. This is a model which has been trained for months and months on a very, very large corpus of data. And at the end, what you get is a model which can answer any questions of your choice. You can write code with that. You can teach programming language to this model. You can get the answer of any questions around arts, science, anything. You name it, they just able to deliver it. Now, what is interesting in this is the last point. So this is where our customers are very much interested. Now, what this point says is that the customers are very much interested to leverage generative AI and these large language models into their application, but they are even more excited how they can leverage their own personal data or their own proprietary data and then leverage these large language models to transform their business. right? So it's not like they will just use the model as is, but they want to make use of that along with their personal, and when I say personal, it's basically the proprietary data, right? Because the large language model is trained on internet scale data, general purpose data that we have on the internet, right? It may not know the context or the taxonomy or the terminology that you use in your business. And today's talk is more around this, how we can make use of our custom data with any of the large language models. Now, before we dive into large language models, let's see what is the difference at a very high level. So this is the traditional machine learning model that you might have seen. We take some data with its label, and we train different models to solve different problems. For instance, we can create a model M1 for text generation, model M2 for summarization, and so on. So this is a traditional way to create a machine learning model and put that in production to accomplish different tasks. Now, how this generative AI or large language models, which are typically known as foundational models, differs is this. Here, we don't take all these labeled data. We just create one foundational model with unlabeled data. And this single foundational model can do all these different tasks, right? So this is the power and generalization of the foundational model with respect to the traditional machine learning model. Now, when we think about generative AI on AWS, you might have heard of a few of these services. We have these three different segments, like you can use Amazon Bedrock to make use of large language models using one single API. So you can make use of the large language model from AWS, which is Titan. But not only that, you can use any third-party model from different vendors, like Meta or Cohere, and so on. So the advantage that you get on AWS using Bedrock is that today you might start with, let's say, one of the models from Meta. Tomorrow, you might decide to experiment with Cohere or, let's say, Amazon Titan. You don't have to change anything in your stack. All you have to do is just change one line of code, and things will start working. You don't have to change the platform or anything of that sort. So this is the advantage that you get with Amazon Bedrock. And in terms of the infrastructure, you can make use of EC2 instances like Titanium, Trainium, and Inferentia for high-performance training and inference in your infrastructure. And lastly, we have Amazon Code Whisperer. Have you heard of this service? Yes? Yeah. So this is, you can think of it as a AI code companion. And a few weeks back, we also announced Amazon Code Whisperer for CLI. Like you can have it on your CLI on your Mac. So you can make use of that to generate code as you write code in your app, for your organization. Now, before we jump into our topic today, vector store, I just have one small poll. So I'll give you 40 seconds or so. Just answer this very difficult question. So these questions are very difficult. You have to work really hard to go wrong. So let's take 30 seconds. Is it working? Yeah? OK, perfect. All right. Awesome. Yeah, so this is the model that we call is foundational model. So this is the model that you will, this is the term that you will hear whenever you discuss anything around large language model or generative AI. All right, so let's move on. So let's try to answer this question. Let's say you have this question, and imagine that you are building a product which you sell in different platforms. Let's say you have this question that which are the products got the best review on this XYZ platform. You can think of any platform, let's say Amazon.com, in last 15 days. So let's say you are the marketing manager or you are the product manager of your company, and you are asking this question. Do you think any large language model can answer this question? Yes, no, no. Right, exactly. Let's see this question. Who won the ICC Cricket World Cup? Before that, how many of you know cricket? OK, that's good. So when I wrote this question, actually, the final was on that day, but we lost it. So yeah. Yeah. So this happened just a week back. But the large language model won't be able to answer this question. Why? Because of knowledge cut, right? The large language model might have been trained till September, and this final happened on this month, on 23rd. Similarly, in the previous question, you have asked a question about your product on a certain platform that has no, I mean, the LLM or the large language model have no idea about. So it can give some answer based on the data that it has been trained on, right? So this is the problem that we want to tackle. And this is the problem or the limitation of any large language model. So now let's see what are the inputs and outputs of foundational models so that we can solve this problem. So we will go back to this problem once we have or think about some solution. So if you think about a foundational model, this is how it gets trained. You take a large corpus of data. We talked about it a couple of times so far, and we trained a foundational model. And then you can ask some question. It could be anything like, let's say, explain thermodynamics to a middle school student, and it will give you an answer. Now, this question, it's very trivial, right? So at least in today's context, it's very trivial. But this is nothing specific to your domain, because the large language model can answer this question because it has been trained on a plethora of data using Wikipedia and internet crawl, right? Now, this will not work for the question that we just asked about, right? Like who won the ICC Cricket World Cup, and what is the best platform, or where my product performed well in the last 15 days, right? So we need to customize something, right? So let's see how and where we can customize. So this is the first way that you can customize. What you can do is you take the foundational model and then do a fine-tuning, OK? So what happens is these large language models are basically based on deep learning or deep neural networks. And what happens is in fine-tuning is in this deep neural network, you just fine-tune the last couple of layers with your data, right? So what happens is, at the end of this fine-tuning, the model weights remains the same, but only the last few layers of the neural network, the weights of those gets changed. And how you will train? You will train with your personal data, right, or your proprietary data. So this will consume some time. This will consume some resource. And obviously, this is not that easy, right? You need to have that machine learning expertise in your organization to do that fine-tuning. Now, the other way would be to pre-train the model itself. And this is very much common in very big financial organizations or medical research organizations, where you know that the terms that are used in medical research is not available outside, right? So you have to train the large language model in your premise or in your system. When I say in your system, it's like you have to do it on AWS or anywhere, but with your own data from scratch. So in this case, the weights of those neurons or the deep neural net gets changed. The whole network will get changed. So this is even more time-consuming, and this needs even more resource. And let's see what is the third one. So third one is the information retrieval. And this is where we are going to discuss today, and how you can leverage vector database to accomplish this. So in this case, what you do is you actually do not touch the large language model. You don't do anything in the large language model. What you do is you take your data, you store it in some place. For now, just think about it as a database. And then when you ask a question, you don't ask the question directly to the large language model, but you ask the question first to this database and retrieve some information, relevant information, and then you ask the question to the large language model with your question and some relevant information that you get from this database, right? So the database that we are having here is a vector store or a vector database. right? So this is the model, or this is the solution that we are going to talk about now. And we will see how we can store our data into vectors, into a vector store, and then retrieve information out of that. And that's why we have this name as information retrieval, because what we are essentially doing is we are first storing our information in the form of vectors in this vector database, and then when we ask a question, we first retrieve some information from this vector database, and then we ask the question along with the information that we have retrieved from here, right? So you can think of it like, let's say you ask a question about, let's say, who won the cricket match, and in the vector store, you will have the results of all the matches in last 30 days. So it will take all the results, like relevant results, and it will give, create a new prompt and then send it to the large language model. And we will dive into that in a while. So before that, let's dive into vectors. So what is a vector? So this is kind of a high school thing. So vector has magnitude and direction, as we all know. But in the context of computer science, you can think of it as an array of numbers, right? So here, let's say you have a text like, I am at reInvent 2023. So what the vector representation would be is some numbers like this. So in this case, we have how many? 1, 2, 3, 4, 5, 6. 6 numbers. That means it's a 6th dimension vector. But in real world, you will see that dimension could be very, very high, right? But the idea is you have to convert your text into this vector. And why vector? Because later on, what we actually want to do is we want to find out similar information based on the question that we ask, right? So we need to somehow have some mechanism to find similar information. And vectors can help us to do that. And we will see later on how we can use some mathematical constructs to find similar vectors. OK, so now, as we discussed, this is nothing but just a representation of number. And in real world, you will see the dimension of each vector is around 1,536. That is kind of a default. But you will see dimension of more than 1,000 or even 2,000. And this is used because, as we just discussed, we can query, we can classify the information in a better way from a machine learning perspective. OK, so now the most important thing, right? How we can store this vector. Now, first thing is we have to create these embeddings, right? So let's say you have this information. You have documents, images, audios, and so on and so forth. It could be anything. Now, the first thing that you need to do is you need to convert that information into vectors. Like in the previous example, I just shown you that you can create a vector of 7 numbers when I said that the text is I am at reInvent, right? So those 7 numbers is just random numbers. But in real world, you have to find a right way to embed your information. So for that, you need to use some machine learning model. So here, we can use Amazon Bedrock, Titan embeddings to convert this information into vectors, right? So at this point, all your information, whether it's image, document, audio, all are converted into vectors. And once that is converted, what we will do is we will store that into a vector database. OK? So once you store that into the vector database, we are done, right? So we don't need that information anymore, because everything is here in an embedded format. So this is a production-ready vector store. And we will get into what vector store we can use on AWS. But as of now, you can just imagine that all your information is now kept in this vector database. So now, when you ask any question, what you will do is this. Would you ask this question directly to the large language model? Yes, no? No. Good. So we will not ask this question to the large language model. What we will do is we will ask this question to the vector store, and then we will say that, OK, this is my question. I know that you cannot answer, but tell me or give me some context about this question. So from the vector store, it will try to find the similar vectors or similar information from your vector database and send it back to you. So now you have two pieces here. You have the query and the context. And now you will send that to the large language model. And it will give you the response that you are looking for. And who will do this? So if you think about it, here there are a lot of pieces going on, right? So we are asking some question. It is interacting with this vector database, and it is then asking the question to the large language model. A lot of things are happening. So who can help us to do all of this? So we can make use of this open source framework called LangChain. So like LangChain, we have many other, but one of the very popular framework that we have to make AI or Gen AI-based application is LangChain, right? So my idea of this session is not to focus on a particular service or a tool, but to give you an intuition that how things work, so that later on, when you go back to your work, you can make use of the technology or tool of your choice and try to do something meaningful. So this is what we called RAG, right? Retrieval Augmented Generation. OK, so we have, again, a quick poll. So we'll give 30 seconds. All right, can we have the answers if we got any? Awesome. Fantastic. That's a tough question, actually. Yeah, that's OK. All right, thanks for participating. Yeah, really appreciate it. OK, so enough of talking. So let's see a live example. OK, this is a recorded one, but I'll just walk you through another demo, which is even more interesting than this. But at least I want to give you an intuition how things work, right, in practice. So in this demo, before I start, one of my colleagues, Ricardo, he writes open source blogs every week. Okay? So what I have done is I have created a PDF of all his blog in last 3 months and created uploaded that document and created the embedding for that, and I stored it in some vector data store. And now I will be asking questions based on that PDF. Okay? So, and these are very specific questions, like time-sensitive questions. So let's see how this works. So here, what we are doing is we are browsing the file. So this is the PDF, and we are processing it. So at this point, it is creating the embeddings in the backend. And now you have an option to select which large language model you want to use. And then you can ask some questions. Like here, we are asking who are the top contributors in the open source world in last 2 weeks. So these are the open source contributors. So their names are mentioned in one of his blog posts. Similarly, the second question is, when is the open source conference India is scheduled? So this is a very recent event, which Ricardo has mentioned in his blog. And if you see, this would be able to answer that, because we are retrieving the information from the vector store. So let's wait for the answer. OK, so oh, OK, I think I scrolled it back. Now let's go ahead. Yeah. OK, so it is able to answer the first question. So now let's see the next question. OK, so you can see this on the top, that it says that it is scheduled in October 12th to 13th at NIMHANS in Bangalore, right? So this is how you can make use of vector store to retrieve some information and then ask questions. OK, so we talked about just the text, but it works with images as well. So it's not like only text, right? We saw that in the architecture that you can convert your images, videos, as well as text or audios into vectors. But the demo that we have just seen is around text. But you can do this in, for videos as well. How many of you have used Amazon image search capability? Have you tried that? Very few. How many of you have not tried that? OK, do you have Amazon app on your mobile? Anyone have Amazon app? OK, OK, so we don't have many people here, but try this out. Go back home, install Amazon app, and in the search, in spite of searching for the item, there will be a small camera button, right? Take an image of any photo, I mean, any object, and you will find that it will be able to search and find all those products in the list. You will get the list of all the products. And this is very useful, right? Because especially in US, there are a lot of retails where you have price match, right? So you can always make use of that, right? So I hope you're getting what I'm saying. So you can make use of image search capability as well. Now, when it comes to vector databases in AWS, there are different types of services that we have. The first one is Amazon Kendra. So Amazon Kendra is for people who do not want to write code and who do not want to get into the details and nitty-gritty of creating embeddings and all that. You don't have to do anything of this. What you can do is you can simply connect your data source with Kendra, and Kendra will do the embeddings of internally, and you can make use of that as a vector store. So you don't have to do anything. You can use any of your connectors, like it could be a Google Drive, it could be S3 bucket, it could be SharePoint, whatever. Okay, so you don't need any embedding. That's the most important thing. In this service, you don't need to embed your data. The other service that you can make use of is Amazon OpenSearch. So if you are very much into, let's say, NoSQL or open source technology, you may like to use OpenSearch serverless, and you can use that to embed your data and use that as a vector store. And lastly, you can make use of relational database like RDS and Aurora. And here, you have to use a plugin or an extension called pgvector, and we will see that in the demo soon. And this is for those who are already having relational databases in their organization. So you don't have to create a new vector database for se, right? Because at the end of the day, you should not have silos of data at different places. Your vectors should be created on the data that you already have, right? So you can leverage Aurora or RDS for that. And again, just like any other service in AWS, you get all these flexibility of role-based access control, encryption, authentication, and so on, right? All this goodness of cloud computing or AWS you will get in whatever service that you use. So for this session, we are going to use Aurora or RDS, right? It's just the same service, but Aurora is completely serverless. And we will see how you can make use of Aurora as a vector store. Now, one more poll. So I'll just pause for 20 seconds. OK. Yeah, that's fine. So I think this is a little tricky, but if you are listening to this for the first time, it might confuse you, right? So in Kendra, you don't have to do the embeddings, right? This is the advantage that you get. And this is mostly meant for enterprise-based companies, where they have a lot of data in different places, and they don't want to spend resources to do the embeddings and all that. They just want to connect their sources, and it will just work out of the box. All right, so let's move on. What's that? The answer is Kendra. Yeah. Because the question is, which of the following which of the following provides the out-of-box semantic search capability? I think I have not mentioned that semantic search thing, but basically, which is the service that helps you to store vector embeddings out of the box, right? So you don't have to do anything. Yeah, the question is not that clear. So those for 60%, I think you're fine. Okay. All right, so now let's talk about Aurora and RDS, right? How you can leverage a vector database using these services. So you can make use of Aurora or RDS using PostgreSQL, right? So if you are new to PostgreSQL, it's a relational database which has been for quite some time, almost 35 years. It is developed in University of California, Berkeley, and it has a very, very strong community. If you raise any bug, if you faced any issue, you raise a bug, you will get a response in no time. And you can have a healthy discussion with the community, and you can actually check in the changes and contribute as well. Now, with Postgres, what you can do is you have to have an extension to make it work for as a vector store. So PG vector is the extension that you need to use. And why extension? Because in Postgres, you have many extensions. So you can think of it as a plugin, right? So you don't have to fork the new branch. You can use the existing branch, but you can just make use of plugins. Now, the reason that you have to use a plugin at this point in time is because Postgres has many different data types which supports vector stores, or which supports storing vector embeddings. But it has some limitation. Like there are data types like array, but they have some limitations for semantic search, right? I'll get into that in a while. But with PG vector extension, those limitations are gone away, right? So you can make use of PG vector, which is an open source library. You just have to create a vector like this, create extension vectors, and then if you just run this SQL command called select type name from PG type. So PG type is a meta table, basically the table which is used it's a system catalog table in Postgres. You will see a new type called vector. So just like in programming language, we have int, big int, and so on, right? Float, character. Here, you will get vector. So if you don't use this extension, you will not get this vector type. Okay? So that's the idea. So now let's see how it works. So, and how you can do a query or a semantic search. Now, when you do a query, right, when you try to find the similar vectors, you need to have some mechanism, right? So these are the mathematical constructs that I was talking about earlier in the session that you can make use to find two similar vectors. So you can think of these two vectors as two different text, right? So let's say one of the text might be, I am at reInvent. The another text might be, I am in Las Vegas, right? So these two contexts are pretty similar, right? So in that case, the Euclidean distance would be quite small, right? So this is one of the way that you can find the distance between two vectors. You can also use cosine similarity, which is nothing but the cosine between two vectors. And then you can also use dot product, which is similar to cosine similarity, but here we index more on the magnitude of the vectors. And if you see the last right-hand side of this slide, I have used some symbols here, like less than, underscore, greater than, right? So these are the symbols that you will be using when you are querying the database, right? So, and I'll show you, what that means. Just like if you write a if statement, if A equal to 5, you do something. So in place of doing equality check, if you want to do a similarity check, you have to give these symbols, okay? And we will see that next. So let's say this is a dummy query. I just want to show you how this works in real world. So let's say you create a table, and this table has 2 columns, product ID and embedding. And if you see this, I'm using a vector data type, right? And this is possible because I have the plugin. And now I have to insert some data. So let's say these are the 4 data points that I have. Like the first data point is 1, and then it's vector embedding, 2, and then it's vector embedding, and so on. In real world, these embeddings will come from your machine learning model, right? But here, I'm just trying to show you how things work. And now, if you do a nearest neighbor search, what you will say is this. Select product ID embeddings, where embeddings is similar to this vector. You see this? This is the symbol for Euclidean distance, right? And as distance, and from table test embedding, order by embeddings, okay? And you will get the answer like this, okay? So why we are getting only 2 results? Because I have limited to 2. And the way that it is working is, under the hood, it is trying to find the distance of this point, which is in the query, which is in the query here, with respect to all those points. And the top 2, in the ascending order, we are showing here. You're getting the idea of how you can do a similarity search in a database? Now, you don't have to do all this in SQL. I just want to show you how things work under the hood. From the application standpoint, you will write all the code in Python, Java, whatever language you prefer. Okay? So now let's see the final demo, where what we will be doing is we will be screening resumes. Okay? How many of you are hiring managers, or you are part of the hiring process in your organization? Okay, plenty of you. So you might agree that when you open a rack, you get lots of resumes, right? And it's very difficult to screen them. So we will see how you can leverage this. Now, again, this is just a dummy example, but the context is how you can make your life easier with large language model and vector store. Before I jump into that, I just want to show you the architecture so that you can connect the dots when I show you the demo, okay? So as a hiring manager, what you would have is a job description and a bunch of resumes, right? This is the resumes that you will get from your HR team. Now, let's say you have appointed a couple of engineers to take the interview, right? So you will say that, OK, give me top 5 resumes, because my engineers are free. They can take some interview. Give me 5 resumes, right? So these are the 3 inputs from you: the job description, the number of resumes that you want, and bunch of resumes. With me so far? Yes? OK, perfect. Now, the first step we need to do is we need to do the embeddings of these resumes, right? After that, what we have to do? We have to save those embeddings somewhere. So we will have those embeddings, and we will save it in vector database. For our demo, we will be using Aurora, using PostgreSQL. But it could be any vector store of your choice, not only AWS, but also any of the open source vector stores that we have. So at this point, I'm done with this, right? So next, what we have to do is, I don't know if this is visible. The way that you can accomplish this is like this. The last line, from LangChain vector store, PG vector, import PG vector. Okay? So this is, I'm using LangChain. If you remember, we do all of this using LangChain as a framework. And what you do is, you can simply say PG vector dot from documents and all the resumes. And what it will do is, internally, it will do the embeddings. It will talk to Amazon Bedrock. It will do the embeddings and store it in the PG vector or Aurora database. OK? Now, first part is done, right? We have stored the embeddings. Now we have to find similar resumes. How we can do that? We can do something like this. We have this vector store, which is the last object that we have here in the bottom, right? Vector store dot similarity search with score. This is the same thing that we have done using SQL command in the previous example, right? So here, we are saying that take this job description, which is in the form of some text, and the resume count, maybe top 5 resumes, And this will return all the shortlisted resumes. So if you have asked for 5 resumes, this relevant doc will contain those 5 resumes. Okay? Now, let's say I want to go one step further. I just don't want to give 5 resumes, but I also want to give a summary of those 5 resumes so that you don't have to, as a hiring manager, you don't have to open the resume in the first place. You can have a summary of those 5 candidates so that you have a better understanding of who the candidate is. So for that, what we can do is we can use Amazon Bedrock. Now, at this point, I'm not using any vector search or anything. Those things are already done, right? So now I have a text. I want to have a summary of that. And the text is everyone's resume. So what we can do is we can use Bedrock, again using LangChain, and we can leverage LangChain's chain class, and then we can simply use Bedrock and pass on the resumes. So in this line of code where we are saying chain equal to load summarize chain, in this function, I'm just passing 2 things, Amazon Bedrock's LLM and the resume. And the return would be the summary of that resume. That's all. Okay? So this is what we will get at the end. We will get the summary of the resumes and the shortlisted resumes. Okay? So let's see how this works. So all this, the demos that we have shown so far, all these are there in the GitHub, and you can always make use of that after the session. So this is a Streamlit application. OK, and you can try this out at your home if you wish to. So first thing is, we have to have some job description. So you can always go to LinkedIn or any of the career page and copy paste the job description, but just for the ease, I have some job description here, but you can always use any job description of your choice. You can paste it here, and here we can say I need 2 resumes, top 2 resumes. Now there is a tab called Download Sample Resumes. This is for you. In case you want to try out, you don't have to wait for resumes to come, right? So you can just click on this, and you will find some sample resumes downloaded on your laptop. OK, so now I have to give some resumes. So let me browse and add all these resumes. OK, so I have total 7 resumes, 3 in the first page, 3 in the second page, and 1 in the last page. And now I can make use of any of the large language model, right? So here we are using Amazon Bedrock, and this is the beauty of Amazon Bedrock, right? So you can make use of any of the LLMs, like Claude, Titan, or anything. And in the back end, it's just one line of code, OK? And I can just click on Help Me Analyze. So what is happening under the hood is, at this point, LangChain is calling Bedrock, doing the embeddings of those resumes, and storing it into Aurora database, and then doing a similarity search or search for the most apt resumes. And after that, it is again using Bedrock to find the summary of that candidate. Okay? So if you see this, it is still working. And it is saying that uploaded resumes 3, total resumes 2. And why 2? Because I have mentioned to give me 2 resumes. And if you see this here, there is a small summary for that resume, and there is a match score, which is nothing but the probability of this match, which is around 49%. And this one is around 51%, and you get the summary of that. OK? So if you want to, let me just show you that as well. So let me just open the code. So this is the code in the back end which is running. OK? So you can always do a GitHub clone, and you can just make use of that. So I want to show you one small thing where, yeah. So if you see this here, not sure if it is, let me just try to increase the font. Yeah. So if you see this, you can use any of these different models, right? And you can write just few lines of code so that it can pick the right model. And here we have an if-else statement because there are different, there is some different way that these models takes the input. So the arguments are a little different. That's why you have if-else statement. But going forward, it might happen that we are standardizing it across the industry so that you don't need any if-else statement, right? You take the model, you just pass it on, right? So this is a very evolving field, and every passing day, things are getting changed. But the idea is, when you use Bedrock, you don't have to worry about different vendors, models. You can make use of any of them, okay? Now, one last thing that I want to show you is in the backend, in the database side, right? So this is this is the vector data store or the Aurora database, right? So we have created, we have just uploaded few resumes, right? So we should be able to see that in the backend database. So let me just show you this, okay? So I'm just running this query. Oh, okay, so that is, I have to close this. Okay. So if I just run select all from LangChain PG embedding. So this is a table which LangChain creates when you create an object, right? So automatically LangChain will create this table under the hood, okay? So now if you see here, you have all these embeddings, right? So you can forget about these two columns. This is collection ID and UID. This is a unique ID. And these are the embeddings. And each embedding is of size 1,556 dimension. And these are the documents. So you might ask, okay, I just give 7 resumes. Why am I seeing so many entries, right? So internally, these documents are getting chopped into small chunks. And those chunks are getting saved as vectors, okay? So this is the raw data, and this is the embeddings. When the search happened using these embeddings. It's not like a relational database where you do a select query like select employee, where employee ID is 1, 2, 3. Here we don't do that. Here we do similarity search, and that is where this Euclidean distance, cosine distance, dot products comes into picture, right? So here, when you do a search, you find the similar vectors or the closest nearby vectors and just return the respective resumes. Yeah.
In your example, whose responsibility was it to create the vectors for the job description?
Yeah. So that's a very good question. It's the job of the PG vector. The job of LangChain. Because in the LangChain, I am passing the text, that job description, along with the model. So it will automate. So you have to pick the model so that LangChain knows which model to use to do that embedding.
Because it needs to be the same.
Yes, that's correct. Yes. That's a good question. Yeah. Yeah. Yes.
So when LangChain does this, does it use summarization and then vectorize summaries, or is every word?
No, every word. It doesn't. It's a lossless. It's not. It doesn't compress or anything. It's just the same data. If you read that data back, you will find the whole resume, right? And that's how it is returning it. Because when it is returning, if you have noticed, it is returning a summary and the resume. Yes, you have some question. Yeah. Yeah.
How do you know to keep the document together? So if you're breaking up into different
Good question. So this is where we have this embedding IDs, collection ID, and unique IDs. So each document will have a unique ID. When you chop it, so you know that which is the part of that document. Good question. Yeah. Okay, let me just go back to the slide so that. Yeah. Any other questions? We are almost done, so just one last slide. So this is a demo GitHub repo. Yeah, I'll come back to you. this is a demo repository. It has lots of demos, so I'm keep on adding it here. There's an interesting demo on recipe. You can give an image of a few of the ingredients. It can give you some recipes. So these are the fun projects. It's not like something production ready, but you will get an intuition as a developer that what are the different possibilities. And once you know the basics, you can do build on top of that. Okay? So I will just take, if you're done with this, I'll just take one last poll, and after that, we can go ahead with questions. Okay, thank you so much, everyone, for your time. Really appreciate it. Yeah.